Let's solve the remove nth node from end of list problem on LeetCode. In this problem, given the head of a linked list, we need to remove the nth node from the end of the list and return its head. So in example 1, we have 1, 2, 3, 4, 5. N is equal to 2. Starting from the end, this would be 1, this would be 2. Therefore, we need to remove the node 4. And after we do that, we have 1, 2, 3, 5. So we're going to take a look at the example 1 on a drawing to see what exactly we're going to do. So like that previous example, we have head 1, 2, 3, 4, 5, and obviously head is the pointer to this list, so we'll just write that here. So the way we're going to solve this is we're going to initially create our own list, and within this list we can assign it any arbitrary value, so for example 0. And obviously once we create the list, it's going to have a pointer. We can call that list. So what we're going to do is, first and foremost, we're going to retrieve the number of nodes in our original list. So in this case, 1, 2, 3, 4, 5. This is going to help us keep track of the node which we're on. This node is going to start at 0. So 0, 1, 2, 3, 4. And obviously our nodes are equal to 5. So you can think of it sort of a for loop with an array that starts at I equals 0 and ends when I is less than array.length. So it's the same idea here. We're going to retrieve the number of nodes, and this is going to start at position 0, and we're going to stop once we reach the end. So the first thing we're going to do is we're going to retrieve the number of nodes in our original list. This will help us keep track of the node which we're currently on, starting at 0, which is the first node. Then what we're going to do is we're going to create two dummy pointers. So we can call this dummy 1 and this dummy 2. Now something I want to mention is that it would be hard to retrieve the nth node from the end. Like in the example, they gave us n is equal to 2, which means we're looking at node 4. But if we go back to the fact that we're going to retrieve the number of nodes in the original list, and we're going to use it to keep track of each node, starting at 0, this would be 0, this would be 1, this would be 2, this would be 3, and this would be 4. And n is equal to 2 is pointing at 4. Therefore, with our count, if we use the number of nodes which we retrieved, which is 5, and subtract n to it, we'll get the position of the node that we need to remove. So 5 minus n, which is 2, is equal to 3, starting at 0, 0, 1, 2, 3, which is at 4. And that's how we're going to know which node we need to remove. That's why retrieving the number of nodes to keep track of the node which we're currently on will be helpful. So what we're going to do next is we're going to keep iterating until d1 becomes null. And what the idea is that while d1 is not null, we want d2.next to point to what d1 is pointing at. We want to update our d2 pointer to point at d2.next, which is this one now. And then we want to update d1 to point to d1.next, which is this one. So now it would be pointing at 2. And we want to keep this process going until two things happen. First, until d1 becomes null, otherwise we need to stop because there's no more nodes to process. And the second more important thing we need to check is the fact that we need to skip the element which they want us to remove. So in this case, that would be 4. Remember, we're going to get the number of elements in our original list, 5. And then what we're going to do is we're going to subtract it by n, which they gave us in the given, to get the position of the node that we need to remove. So 5 minus n, that's 5 minus 2, that's 3. This is starting at 0, so 0, 1, 2, 3. Now what we're going to do is we're going to have a integer variable called count that begins at 0. And it's going to increment every time we transition to the next node. So first it's at 1. And once we finish this process of updating our pointers, count is going to update to 1. And we're going to keep incrementing count until count is equal to the number of elements minus n, which is 3. So when count is equal to 3, we're going to stop. And we're going to write a sequence of code that skips this node by updating these pointers in the correct fashion. So let's begin coding now. So first and foremost, I'm going to create two integer variables, count1 and count2. So int count1 equals to 0 and int count2 is equal to 0. We're going to use int count1 to find the number of elements in our original list, and int count2 to keep track of the element which we're on, starting at 0. And I'm going to also create a pointer which is equal to head. So we have head which points at this list. I'm going to create another pointer so I can temper with that pointer and keep head the way it is. So list node dummy is equal to head. This way we can transition through the nodes of our original list without affecting our head pointer. So head will always keep pointing to what it originally was pointing to. Now I'm going to retrieve the number of elements in our original list. And the way we're going to do that is like this. While dummy is not equal to null, dummy is equal to dummy dot next. And actually before we do that, I want to increment count1 plus plus. So count1 originally starts at 0, while dummy is not equal to null. Dummy originally points at 1. Is that null? No. So dummy is now going to be pointing at 2 because dummy equals dummy dot next. And we're going to increment count, so count is now 1, and we're going to keep going until dummy is at a null value where we escape this while loop. With the number of elements now figured out in our original list, I'm going to reset dummy to point back to what head is pointing to. Now I'm going to create our new list, which we're going to link variables from our original list to. So list node list equals new list node, and we can give this any arbitrary value. I'm going to put 0. Now I'm going to create another dummy pointer to this list, so this list remains unaffected, or this pointer remains unaffected. So list node dummy2 is equal to list. Now we need to attach nodes from the original list to our new list, and we need to skip the node that they want us to skip. So let's do that now. Similarly, we're going to say while dummy is not equal to null. So I'm going to keep updating our dummy pointer on our original list until we reach a null value. That's where we stop. And I have a typo here. So the first thing I'm going to check is if we're on the node which they want us to remove. And the way we're going to do that is we're going to check if count2 is equal to count1 minus n. If that's the case, I made a typo again. So let's say we reach a point where dummy is pointing at 4, and we know that 4 is the element we need to skip, and this is going to be true if we're on that node. What we're going to do is, since dummy is on this node, we're simply going to skip this node. We're going to update dummy to point to what's actually after this one, so dummy.next. So dummy equals to dummy dot next, and then we're going to increment our count2 so we can process remaining nodes. Otherwise, if we're not on the node that we want to skip, then we just need to attach the nodes to our new list. So let's do that now. So dummy2, which is originally pointing to the first node in our new list, which is 0, we're going to have dummy2.next point at what dummy is pointing at. So in this case, it would be pointing at 1. Then we're going to update dummy2 to be pointing at dummy2.next, like we saw on the visual example. Then we're going to update our dummy pointer to point to the next node. So dummy is equal to dummy.next. Finally, we need to increment count2 to process the next node. And then once this is all done and we have our list, our final node in the list should be pointing to null. So we need to make sure that's the case. So dummy2.next is equal to null. And we need to return list.next so we can skip the arbitrary value which we assigned. So let's submit our code and see if it works. There we go. beats 100%. So that was the remove nth node from end of list problem on LeetCode. I hope you found that video helpful, and thanks for watching.